Hey fifth graders, it's Mrs. Trombley. Today we're going to complete some workbook page to problems together, and I would call this kind of the odds and ends. We're piecing everything together so we can wrap up our Unit 1, adding and subtracting fractions with unlike denominators. So you're going to need a pencil and you're going to need your workbook page packet. And I listed the problems in Schoology, but you can kind of just follow along as we go, that's fine. So we're going to start on page 29. So you should be on page 29. The top of it looks like this. And we did a couple of these in class yesterday. So I just kind of want to recap what we had learned. And basically we learned that we can estimate our solutions, and that will help us to check to make sure our answers are correct, okay? So what I'd like to do is just problems 7 and 8. So hop down to the bottom. These two problems right here. So it says use any method you wish to estimate the sum or difference. Remember, the sum is just the result of an addition problem, and the difference is the result of a subtraction problem. So that's all those directions mean. And we spent a lot of time focusing on whole number estimation yesterday, and I'd like to just spend a little bit of time on rounding to the nearest half. And we've been doing that in our number talks. So for number 7, it says 10 1/5 plus 5 6/11. And it wants to give you to give an estimate and then find the sum. So for 10 1/5, I could ask myself, is this 1/5 closer to a half, or is it closer to a whole? And if you only have 1 out of 5, like half of 5 would be 2 1/2, or you could look at this as 2/10, right? We could multiply those both by 2, and 2/10 is definitely not closer to a half than it is to the whole number, right? So when I look at 10 1/5, if I'm giving my estimate, I would round that to the nearest whole number, which would be 10. Now when I look at 5 6/11, I know that 6/12 is a half, right? So instead of rounding this to the nearest whole number, I can get a more accurate estimate if I round to the nearest half. I'll get closer that way. So I wouldn't call this one 6. I would call this one 5 1/2. So for my estimate, I would do 10 plus 5 1/2, which is 15 1/2. And again, I didn't round this one to the nearest whole number because 6/11 would be closer to that halfway point than it would to 5 or 6. And again, the reason that we did that is because 15 1/2 is more precise than just saying 15 or 16. So now let's actually solve this out. That's what it means when it says sum, like let's find the sum. So I would multiply the 1/5 by opposite fractions denominator because 5 is not a factor of 11. I'd multiply this by 5 over 5. So now I have 10 11 55ths plus 5 30 55ths. All right, so let's add them up. 10 plus 5 is 15. And 11 plus 30 would be 41 out of 55. So 15 and 41 55ths, and our estimate was 5 1/2. Does this seem like a reasonable answer? Yeah, I would say that 15 and 41 55ths is pretty close to a half. The 1/2, the 41 55ths. Sorry, it's about like 4:30 in the morning right now. I'm doing my best, but I've only had 2 cups of coffee so far. Okay, so with this, if you would have said, 5 6/11, that's 5 away from 6, and it's 6 away from 5, so it's closer to the 6. If you had an estimate of 16 and you rounded to the nearest whole number, would you still be getting a reasonable answer? Yes, so either one is fine. Our purpose for giving the estimate is to make sure that we did the problem correctly. So normally you solve your work, right? And then you just move on to the next one. What I would suggest is after you solve your problem, say, okay, well, 10 plus 6, yeah, that should be about 16. Oh, my answer's about 16. That's literally how long it takes. You should be doing that with every single sum or difference you get. All right, take a look at number 8. I have 6 2/9, and when I look at 9, I know that half of 9 is like 4 1/2, and 2 is less than that, right? So I wouldn't say that 6 2/9 was close to 6 1/2. I would say it's closer to 6. So that's what I'll use for 6 in my estimate. And now this is subtraction, it's a difference. 2 5/6, definitely closer to 3 than it is to 2 1/2. So for my estimate, I would use 3. So then we're actually going to solve it and see, is our difference close to 3? Is our answer reasonable? And when I see 9 and 6, yeah, you could use 54 if you want. You could even use 36 if you want, but I would love to use 18 because that's the LCM. That's the lowest common multiple that 9 and 6 have in common. So to get 18, I would use 2 here and 3 here, because when you do that, you get 18 on both bottoms, and your bottoms need to match. So I'd have 6 and 4/18 minus 2 and 15/18. And of course, we have to go to our neighbor's house and borrow again. They're so tired of us. So I'm going to borrow or ungroup this 6 and make it 5. And when I give one whole to something with a denominator of 18, that means I'm adding 18/18 to this 4/18. So I'm just going to write plus 18 like that. There's not that much room, I know. So over here, my new problem is really 5 and 4 plus 18 is 22/18 minus 2 and 15/18. So I can do this now, right? We borrowed. And when I do 22 minus 15, I get 7/18. And 5 minus 2 is 3. So our estimate was 3, and our difference is 3 and 7/18. Now I know 9/18 would be 3 1/2. So I would definitely say that this is reasonable. You know, if I had like a difference of 8 then, and my estimate was 3, then I might say, oh goodness, I added on accident. So the estimate just helps you to go back and check your work. All right, that's all I wanted to do on this page. Now turn to page 30. And on page 30, the next page, we're just gonna do 15 and 17. Like I said, it's kind of just a little hopscotch today, putting everything together. So for numbers 15 and 17, you're supposed to answer the question, is the answer reasonable or unreasonable? Explain. So reasonable means that it would make sense based on an estimate, okay? So when you look at number 15, if I want to answer the question, is 8 and 29/30 reasonable? I'm going to estimate the solution to this one, okay? So we use that by rounding. So if I have 2 and 4/5, I want to ask myself, okay, what is 2 and 4/5 closest to? Is it closest to 2, 2 1/2, or 3? Well, 2 and 4/5 is only 1/5 away from 3, so it's definitely closer to 3. Then I'm going to look at this 6 and 1/6. Is 6 and 1/6 closer to 6, 6 1/2, or 7? It's only 1/6 away from 6, and it's 2/6 away from being 6 1/2. So I would use 6. And we get an answer for our estimate of 9. Now I want to look at 8 and 29/30. 8 and 29/30 is only 1/30 away from 9. Would you say that if you got 8 and 29/30 for your final answer and your estimate was 9, that your answer is reasonable? I sure would. So we're going to say reasonable. Our estimate is 9, right? So if our estimate's 9, 8 and 29/30 is super close to 9. So we know we're good. All right, look at number 17. 5 and 5/6 plus 1 and 3/4. And we want to know, is 5 and 1/12 a reasonable answer? All right, so 5 and 5/6, is that closer to 5, 5 1/2, or 6? Well, it's only 1/6 away from 6, so it's closer to that. And 1 and 3/4, that is 1/4 away from 2. It's also 1/4 away from 1/2, but usually we bump those up, right? So I'm going to use 2 for this. You could use 1 1/2 if you wanted, because it's the same distance from them. It wouldn't make a difference to our estimate here. So 6 plus 2 is 8. So if your estimate is 8 and you got 5 and 1/12, would you say that those are pretty close? I would not. No, so this would be unreasonable because our estimate is 8. Now, picture normally, like, you don't have to write this out. It just would take you a second to, you finish solving this problem. You got 5 1/12, and you say, okay, well, 6 plus 2 is 8. Oh, I don't think that's right. That's how long it takes. You should do that after every single one. Okay, now turn your page to page 31. We're just going to do 2 problems on here. So we're going to do problems 1 and 2 on page 31. It says, write an equation and solve the problem. When possible, express your answer as a whole or mixed number. So we know we're not going to leave anything as an improper fraction. All right. So Ariel ran 6 1/4 miles on Saturday. This is 1 3/4 miles more than Harry ran. How far did Harry run? Okay, so think about this for a second. It says Ariel ran, or Ariel, I'm not sure, ran 6 1/4 miles. This is 1 3/4 miles more than Harry. How far did Harry run? Did Harry run more or less than Ariel? Hopefully you're saying he ran less, because it says that the amount Ariel ran is 1 3/4 miles more than Harry. That would mean that Harry ran less than Ariel, okay? So if we want to know how far Harry ran, I should get an answer that's less than 6 1/4, right? So that means what operation is happening here? If you said subtraction, you are correct. So our equation is going to be 6 1/4 minus 1 3/4. Okay, and then put an equal sign there, and let's solve it out over here. 6 1/4 minus 1 3/4. This would be a good time if you wanted to pause me and solve it on your own and then check your work. That would be great. I can't take 3 away from 4, so I'm going to ungroup this 6 and make it a 5. And then 1 whole, if I'm dealing with fourths, would be 4/4. So my real problem is 5 5/4. And I know it's improper, but it's okay because I'm not leaving it as my final answer. I'm just rewriting it while I solve it. And 5 minus 3 is 2. My denominator stays, and 5 minus 1 is 4. So 4 2/4, or, 4 1/2. I'm just going to go this way because I have no more room this way. So my equation would be 6 1/4 minus 1 3/4 is 4 1/2 miles. Now here it says, why is the answer reasonable? Okay, so here's where your check would come in. I would use an estimate. 6 1/4. Is that closer to 6, 6 1/2, or 7? Well, with 6 1/4, I would say you could say it's either 6 or 6 1/2, right? So I'm just going to use my whole number 6. If you use 6 1/2, that's not a wrong way to estimate. Minus, so 1 3/4, is it closer to 1, 1 1/2, or 2? I would say 1 1/2 or 2 would be fine, right? So I'm going to stick to the whole number because that's a little faster. So if you have 6 minus 2, you would get 4, right? If you used 6 1/2 and 1 1/2, would you get anything different? I don't think so. Okay, so is 4 close to 4 1/2? Yeah. So why is the answer reasonable? 4 is our estimate. That's why. Okay, let's do number 2. And we're not doing all the problems on this page. We're just going to do 1 and 2, and then we have a couple more on the next page. Hang in there. After guests drank 4 1/2 gallons of tea, hopefully there are a lot of guests there. It's a lot of tea. There were 2 5/8 gallons left. How much tea was there to start? Okay, so after the guests drank 4 1/2, there were 2 5/8 gallons left. How much tea was there to start? So think about this. If they drank 4 1/2 and there's 2 5/8 left, is the amount of tea that was there to start going to be more or less than 4 1/2? It would have to be more, right? If they drank 4 1/2 and there's still some left, the amount to start with would have to be more. So I would add these amounts. And you can add in any order that you want. So 4 1/2 plus 2 5/8, or 2 5/8 plus 2 1/2 would be fine. In that previous problem, though, order matters. So let's write this over to the side and solve it. We have 4 1/2 plus 2 5/8. And I notice the denominators are not the same in this one. And I don't want to use 16. You could use 16 if you want. But a faster way to get to the simplest form at the end would be to ask myself, can I multiply 2 by something to get 8? And the answer is yes, I can multiply 2 by 4. So I'm going to use 4 and 4/8 plus 2 and 5/8. And now I add my numerators. 4 plus 5 is 9. And my denominator stays. 4 plus 2 is 6. And hopefully that 9/8 is shouting at you, I cannot stay like this, I am improper. And 8 goes into 9 one time. And there's 1/8 left over. So 6 and 1 and 1/8 would make 7 and 1/8. So 4 1/2 plus 2 and 5/8 is 7 and 1/8. And we want to know, why is this reasonable? So let's say this question was on your test and you just finished it. And you'd say, I wonder if I'm right. Okay, well, 4 1/2, is that closer to 4, 4 1/2, or 5? Definitely 4 1/2. Plus 2 and 5/8. Now, 2 and 5/8, if I want to know if it's closer to 2, 2 1/2, or 3, if you were rounding to the nearest whole number, you'd round it to 3, right? But if you're rounding to the nearest half, isn't 4/8 a half? So I would actually use 2 1/2 for this one. And if you didn't, you're still going to get an amount that's reasonable at the end. Okay, so don't get hung up on the 0, 1/2, or whole. If you just, when you're doing your checks, round to the nearest whole number, you'll still be able to know if you're on the right track. But this is definitely more precise. All right, anyhow, 4 plus 2 is 6, and 1/2 plus 1/2 is 1, right? So 6 plus 1, that would be 7. Hey, is 7 pretty close to 7 and 1/8? Yeah, sure is. So we know that we're on track. So 7 is our estimate. That's how we know. And again, on your test, when you take this or an assessment or quiz, whatever, you don't have to write all this out. You just have to say 4 1/2, 2 1/2. Yeah, that answer's probably right because it's really close. Just do a quick check. If you get an estimate of 7 and then your answer was like 2 and 1/8, then maybe you'd say to yourself, oh, I think I did the wrong operation. So that helps you catch it. All right, last page, page 32. I'm gonna do a couple problems on here, and these are problems with more than one step, okay? So it says solve, when possible, express your answer as a whole or mixed number, so we're not gonna leave anything as improper. And we'll just get a couple problems done on here to get your feet wet with everything so be ready for your assignment. Nora read 1/6 of a book on Monday and 2/5 on Tuesday. What fraction of the book does she have left to read? Okay, so let's see here. She read 1/6 on Monday and 2/5 on Tuesday, and I want to know how much she has left to read. I think our first step with this is to know how much she read so far, right? So if she read 1/6 on Monday and 2/5 on Tuesday, if I want to know how much that is so far, that's how much it is altogether, I would add those values. And now I see I have unlike denominators, and if you wrote them vertically, that's okay. And 5 is not a factor of 6. The LCM of 5 and 6 is 30. So I would multiply each fraction by the opposite fraction's denominator, because when I do that, I get the same multiplication problem on the bottom. That means I'm going to have the same denominator, and then I can add them. 5 times 1 is 5, 2 times 6 is 12, and so we get 17/30. Okay, so that's not our answer though. The question is not how much of the book has she read so far, it's what fraction does she have left. So when you look at 17/30, in terms of how much of the book she read, if she's reading one whole book, if I'm dealing with 30ths, that would mean 30/30 would be the whole book, okay? So basically, if I want to know how much she has left to read, there's two ways I could do this. I could take 30/30 minus 17/30 and see what's left. Or I could say to myself, okay, 17/30 plus what is 30/30? Both of those equations would be correct. So I'm going to write this as 17/30 plus what is 30/30. Again, 30/30 means one whole. So if I do 17 plus 13, I would get 30, right? So that means she has 13/30 left to read. All right, so why is this answer reasonable? Okay, so if we use some estimates here, I would say 1/6, okay, that's in terms of is it closer to 0, 1/2, or 1? 1/6 would be closer to 0. And 2/5, okay, so is 2/5 closer to 0, 1/2, or 1? Well, 2.5 out of 5 would be a half, so this is only 5/10 away from a half. So I would say 2/5 is closer to a half. So 0 plus 1/2 is a half, right? And if I want to know how much she has left to read, that means if I have my whole book, 1, and she's already read a half, 1 minus that half in our estimate is a half, right? Because 2 halves make a whole. Is 13/30ths pretty close to a half? Yeah, 15/30ths would be a half. So 1/2 is our estimate. And our answer's really close to that. That's what makes it reasonable. All right, one more. Number 6. A rain barrel contained 32 gallons of water. Bettina used 15 1/4 gallons of water in her garden, to water her garden. Then it rained, adding 6 3/4 more gallons. How much water's in the rain barrel now? So let me box that other keyword. Okay, so there's a whole bunch of numbers in here. This is definitely going to be more than one step. Let's go back to the beginning. A rain barrel contained 32 gallons of water. So that's our starting point, right? It says that she used 15 1/4 gallons to water her garden. So I'd like to know how much she has at this point after she used 15 1/4. And used means we took that away, right? So for starters, we would need to do 32 minus 15 1/4. Now remember, this empty space right here would represent nothing, and 0 is nothing, right? Can you take 1/4 away from 0? Nope, you can't. So I'm gonna ungroup my 32, make it 31, and since we're dealing with fourths here, when I borrow the 1 whole, I would need to put 4/4 here. So 4/4 minus 1/4, you actually get the same denominator, isn't that exciting? It's 3/4. And then 31 minus 15, you can borrow and do all that, but I know that 15 plus 15 is 30, so that would mean 15 plus 16 is 31. If you're like, Mrs. Trombley, I don't want to do that. I need to ungroup this 3 and make it 2, make this 11. 11 minus 5 is 6. 2 minus 1 is 1. You could do that. I don't mind if you do the standard algorithm. It's all good. So we're not done because there's more, right? It says that she used that 15 1/4, so now we're at 16 3/4. But then it rained, and it added 6 3/4 more. So we were at 16 3/4. If you add 6 3/4 more, that means I want to add 6 3/4 to what we had before, which is 16 3/4. So same denominator, 3 plus 3 is 6. And then 16 plus 6, maybe you say, well, 16 plus 4 is 20, plus 2 more is 22. Fine. Or maybe you said, okay, standard algorithm, 6 plus 6 is 12, and carry that 1, and 1 plus 1 is 2. Either way, you get 22. It's all good. 6/4 not okay. 4 goes into 6 once, and there are 2 left over out of 4. And when you put those together, 22 plus that 1 is 23, and then that 2/4 I would recognize as 1/2. So the answer would be 23.5 gallons. Why is this answer reasonable? Well, let's use some estimation to figure it out. To start off, I know that we have 32, and then we subtracted 15 1/4, and you could either use, for 15 1/4, is if you're saying to yourself, is it closer to 15, 15.5, or 16? Either one would be fine. So for this one, I'm just going to say 32 minus 15, okay? And 32 minus 15, you could line that up and borrow and do all that good stuff. Or maybe you could just ask yourself, well, 15 plus what is 32? I know that 15 plus 15 is 30, so 2 more added to that 15 would be 32, so 17 is what we would get. And again, if off to the side you're like, nope, I want to do this. 2, 12 minus 5 is 7, 2 minus 1. Then lo and behold, you get the same answer, so I'm good with either way. All right, then it says that we added 6 3/4 more to it. So 6 3/4, is it closer to 6, 6.5, or 7? Well, it's the same distance from 6.5 as it is from 7. So I would say 6.5 or 7 is fine to use. I'm just gonna stick to whole numbers for this one. So I'm gonna add 7 to the 17. And when I add 7 and 17, like I just think to myself, well, 7 plus 7 is 14, plus another 10 would be 24. Or you can say, okay, 17 plus 7, 7 plus 7 is 14, carry that one, 24. We get the same thing, right? So we got 24 as our estimate. Our answer is 23 and a half. Yeah, that's really close. So we know that we're right. We know it's reasonable because 24 is our estimate. And again, on an assessment, you wouldn't have to write all that out. You would just say, okay, well, 32 minus the 15, or that'd be 17, plus 7 is 24. Oh, I got 23 and a half. Yep, I'm right. It just takes a second. All right, you're done. Thanks for hanging in there. I know this was a lengthy one, but we had to put it all together. Good work.